So hello everyone and welcome to our IT Talk. Today we'll explore how to use generative AI to build prototypes faster without losing quality. I'm pleased to introduce our speaker. It's Ilya Kurnosenkov, Senior Software Engineer at DataArt. After the session, we'll share a short presentation with key takeaways. And now let's pass the mic to our speaker.
Hello, my name is Ilya. I'm a senior software engineer at DataArt. I'd like to welcome everyone. It's nice to see you all here. So, we'll be discussing the rapid prototyping with AI and how to ensure the quality of the generated code. Let's start with the initial problem. The problem we aim to solve was how to quickly create prototypes and proofs of concept. These solutions needed to be both inexpensive and fast to implement. And we decided to use AI for code generation, well, because it's quick and it's cheap relatively. But is it reliable enough? Will it be easy to quickly iterate over the prototype and change the implementation if needed? We decided to check this out by building a relatively simple proof of concept web application using React, Node.js with Express framework as the backend, and Postgres as the database. So we experimented with a few options. First, we tried Lovable. As you might know, it is one of the services that enables users to wipe code some web applications. It was effective for rapid prototyping of web applications, but it often generated unnecessary or unrequested features. Next, we looked at Replit, which was a bit better. It offered more control over the generated output and provided more tools, such as an interactive shell and the database client. In general, it felt like Replit as a product is targeted at people with a technical background, while Lovable is targeted at people without any development experience. We also tested the local setup using Visual Studio Code with the Copilot plugin powered by the Claude Sonnet model. And this was the most flexible and controllable solution of the three, but it obviously required more effort to set up and manage, which might be a drawback for a prototype or proof of concept project where you'd like to iterate quite quickly. However, all the options we tried had similar issues. The generated code usually worked, but that was not always the case. Often making AI-driven changes in one part of the code base would break other parts, even seemingly unrelated ones. Additionally, the AI would sometimes implement features that weren't requested or needed in the first place. My personal feeling is that Claude Sonnet especially likes to kind of over-deliver and tends to add more than what was asked for. So we needed to introduce some quality gate, some way to verify that the generated code met our requirements and did not introduce any new issues. And our first idea to address these issues was to have the AI test its own code. We wanted some very simple solution that would work without requiring extensive setup or much commitment in terms of effort and time. In any case, it would not have made sense to spend a lot of time setting up and configuring the project for some elaborate end-to-end automated testing tool. It would defeat the initial idea of quick and inexpensive prototyping. So we set up a very simple end-to-end testing agent using playwright MCP. This agent would read the test scenarios written in the standard given when then format. A large language model will interpret each step, and the agent perform the corresponding actions in a browser via MCP. The language model also verified the expected outcomes, and this process was repeated for every step in the scenario. And this is how it was set up. The input is a Gherkin scenario, the one in given when then format. The MCP client reads the scenario line by line, sends the prompt with the current step and some system instructions like the large language model roll a few shots, examples of responses, and a list of available MCP actions to the MCP server, which in turn performs the action in the browser and returns back the results. MCP client sends the result of the action to LLM, and it decides if the next step should be executed or if the scenario is finished. And this approach worked surprisingly well, but for simple scenarios. For more complex situations, however, it was challenging, and the tests were often unreliable. It became clear that this method was not sufficient to guarantee the quality, and we needed a more dependable solution. There are probably some out-of-the-box solutions available right now that will work better, but back then we didn't really find any simple to set up tool that would do the job well enough and won't require massive commitment in terms of time and effort. So we decided that we need to move in some other direction and try to find other ways to ensure quality of AI-generated code. Before moving forward, we tried to understand why the AI was failing. We suspected two main reasons. First, the AI lacked the full picture, as the prompt combined with the existing code was not enough to convey all requirements. Second, we were limited by the context window. The entire code base, along with the potentially long chat history, often would not fit, causing the AI agent to forget some important details. So how we decide to address this? Most straightforward solution to address the incomplete picture of the agent was to start adding documentation and specifications to the same repository with the code. This has made them accessible to the AI agent. It was an attempt to provide the AI with a more complete picture. So we were able to reference the docs and let agent search through the specs on its own to find relevant information instead of relying on copy pasting large chunks of specs into the prompt. And we also started using semantic code markup. It is a bit more complex than just making docs easily accessible to the AI agent. We instructed the AI to add doc strings in a specific format to all generated functions and classes. And these doc strings included unique keywords from the specification files, creating a link between the specs and the code. And this approach was intended to build a knowledge graph across the code base eventually. At the top of this graph is the application specification. Its children are the different features described in a bit more detail. those features are potentially described in different files, or everything can be in the same structured specification file. And the leaves of the tree are the concrete code implementations for each feature. This structure provides the coding agent with the necessary context to generate code efficiently using only the relevant parts of the specification. And this allows us to work within the context window more efficiently. And here is an example of our semantic markup in TypeScript. Our proof of concept, as I have mentioned, was a React application with a Node.js backend. So the example is from that code base. As you can see in the code, we used a specific format with sections for purpose, inputs, outputs, and side effects. After experimenting with different formats suggested online, we found this one worked best for us. This semantic markup provides the AI coding agent with the information it needs to apply changes efficiently. When the agent searches for the right place to make a change, usually it uses the retrieval augmented generation. The code base is indexed in a vector database, and the code is likely split into chunks for this. And the additional documentation in those semantic markup blocks is also indexed, providing more anchors for the agent to navigate the code. This helps it find the exact location for changes and understand how those changes might affect other parts of the code base. The side effects section is particularly useful for this as it highlights potential impacts on other components. Clearly defined inputs and outputs are essential for the agent to understand the contracts that a particular function or class must follow. The agent should be prompted to keep these contracts up to date and in line with the implementation when making changes. And this also makes it easier to spot if there was some change made that altered the contract. It will be clearly seen in the diff. So this change allowed us to make changes a lot more reliably, and the total amount of issues or bugs or unrelated or unrequested changes, it just dropped drastically when we first introduced that kind of doc strings in the code. So let me go through what has worked for us. Let me share some key findings from our work. We should use version control, obviously, and this is crucial for code review, which is actually a must when using generative AI. The biggest mistake that can be done is just using what was generated by the AI without really understanding what was done and without any review. So in that sense, version control is our main tool. Then it's important to set up clear instructions for the AI agent. Tools like Cursor or Gemini CLI or Claude Code have configuration files that can make the workflow much easier. It's also possible to use just the plain text files with prompt examples. This will allow for quick copy and pasting of the prompts, and different prompts can be created for different tasks, such as architectural design, implementation, or bug fixing. This is very simple, and it doesn't require any complex orchestration or tooling. You can use Gemini CLI for that kind of setup and just reference the file with the prompt, and the agent will read the file and do whatever is specified there. Also, it's possible to use multiple agents for parallel tasks. Git work trees are excellent for this, as they allow you to check out different branches into separate folders and run agents on each branch separately. And after that, you can merge the changes back into the main branch and resolve any potential conflicts using agents as well. Also, it's important to invest time in iterating on specifications and creating the sensible implementation plans for the agents before starting to generate the code. And tools like Specit or Kiro can help with creating better specs and ensure that the plans cover all the requirements. Using large language models with large context windows are especially useful for architecture and planning. For example, Google AI Studio with Gemini Pro has a very large context window, and it's possible to put quite a lot of documents and quite large chat history into the context window, and that helps quite a lot. On the other hand, it's possible to use models with smaller context windows for actually generating the code. For example, a model like Grok Code Fast is relatively quick, and it generates decent code. And the price per token is smaller than for more complex reasoning models. But smaller models require very good input to produce high quality results. And they will rely heavily on the specs and documentation that were generated by more capable models during the planning phase. So it will depend on the quality of the docs that were prepared beforehand. And in general, the approach should be similar to best practices for working with human developers. The architecture should be really thought through. The implementation should be split into loosely coupled components that each require minimal context. The documentation and specs should be well written. And overall, the process ends up being this whole process of AI-assisted code generation tends to be closer to a waterfall model than an agile one. Using AI for code generation makes it more affordable to spend more time on upfront design and planning, which pays off during the implementation. The cleaner and more concise the specs are, the better quality will be the code generated by the AI agents. And I think in general, the general trend would probably be towards spending much more time on design and planning, because the implementation phase can be potentially delegated to AI agents. And in that sense, we might end up writing and debugging specifications that would be compiled into the code by the AI, like we do with the programming languages today. So the human work, the work of the software developer or engineer, will move to a little bit higher level, and most of the work will be done specifying and describing all the use cases and just describing how software should work and defining the contracts between the components. And all the rest will be handled by the AI itself. Okay, I think that's all for our short overview. Let's see if we have any questions. I think I'll need some help with the
We didn't,
questions.
yes, we did not have any questions for now, and waiting from our participants.
Have you tested test-driven approach? For example, first you write specs and tests, and only then implement. Kind of. We were using the spec-driven approach. So the specifications were written first. And as for the tests, for this particular POC implementation, we decided that we will stick to writing the specs and using the and relying on the semantic markup in the code more than on the tests. We tried to create the quality gate that we needed using the end-to-end testing agent that I've described, but in the end, we just settled on using the semantic markup, and basically that's it. But for the production projects, I think that would probably a good option, a good way to move forward and start with the specifications, and also write either with the and set up some tests, either generate everything with the AI or write the scenarios with human in the loop, and then use those scenarios with the testing agents to check the implementation. And after that, proceed to actually generating the code and running the tests and making sure that everything is implemented according to the tests. And probably also the testing framework should be completely separate from the implementation, so that it will have the testing agent will have access only to the scenarios and, for example, a running application, so that it won't it will treat the application as the black box. Okay. What additional measures would you recommend to ensure quality and reduce flakiness in complex scenarios when developing AI prototypes? As I have said, both options, semantic markup and some additional quality gate that can be the end-to-end testing agent using some scenarios is a very solid choice. It also might be possible to set up the testing agent and use it for exploratory testing without any predefined scenario. Just give that agent access to the requirements and ask it to figure out what needs to be tested on its own. This might be also a potentially good approach, but personally, I have not tried that yet, but I would like to do it. Are you using the prototypes later for production code? Not at 100%, but some parts of the prototype will be used for production implementation. Basically, we are in right now. We are in the process of working on the developing this proof of concept and moving from the proof of concept stage to the more production ready code, and we are reusing some artifacts that we produced for POC. Any recommendation on how to split design into tasks, vertical by end-to-end features or horizontal by layers of the app? I would say that vertical split would be more useful, and I think that it's also a good idea to leave some room for the agent to actually figure out the best way to implement it from the technical point of view. For example, if you will be using the Spec-It framework, it explicitly states that first steps when you are working on the feature specifications, you should not mention any technical details like the stack or how you would like to split the layers. You need to focus on the features of the application. So it's user-facing features or some requirements that some non-functional requirements, and only when those the specs on that level will be ready, it will be possible to proceed to the next steps where the agent will first generate the implementation plan, and after that it will generate the separate tasks based on the implementation plan, and those tasks are will be ready for actually be used in code generation. Those tasks will be inputs for the agents that will generate the code. How would you suggest to approach to the case when I need to develop some interactive prototypes based on existing product? Okay, so the best results at least for that approach are for the greenfield projects, but it's also possible to use it for the brownfield projects. But the preparation phase might take a bit longer. I have tried to use it with the existing code base that's not in that particular POC, in another project. And I have found out that using the Gemini CLI it works quite well for, say, small or middle-sized projects. I have not tried that on very large projects, but for like medium-sized, I don't know, web application plus a bunch of microservices, it works quite well. And Gemini CLI was used to generate those semantic markup comments in the code. Of course, it will produce quite a lot of changes that you will need to review and read through all those comments to make sure that they actually make sense and they are describing everything correctly. And after that, you can just start working with the spec-driven approach. You can start using the spec-it framework in that project. Given that the semantic markup is there, the agent will be able to figure out what to change and won't break things too much. How much faster you managed to implement the POC with the help of AI? How big a gain have you managed to achieve, say 20% faster than traditional approach? The initial POC iteration, the time from like start of the project and till I've got working web application that looked like more or less what was required, took about 4 hours. After that, there were several iterations until we managed to get the exact result that we wanted. And it took about, I don't have the exact numbers, but it was less than 40 hours, less than a week. I think for traditional approach where all the code created for that POC would have been written by a human developer, I think it would take 3 or 4 weeks. Okay, so how much time you spend on prototype? I have just answered that. Do you involve business analyst in writing specs? Do you need BAs at all within this setup if developer and AI does all the job? There is still work for the business analyst in that setup. It actually depends on the size of the project. For POC, we did have some BA work done before we actually started the implementation, because as an input for AI agents generating the POC, we had some existing documents, but they were also created using AI tools. This might be a bit out of scope of this discussion, but it's still a required step. Okay, hope that answers the question. Yeah, I'm curious of when AI agents will replace developers. What time do I have to prepare? That's very good question. But the answer is not that simple. So definitely our work as developers, it will change. It will change quite a lot. as I have said, I think we will move to a higher level. We will be working. We will be spending more time writing the specifications, making sure that there are no logical inconsistencies there, that all the edge cases are coded, that the system in general is has a like solid implementation plan, and the architectural design is making sense. Sorry. But there still be a place for developers. You see, there are some even theoretical limitations on the on what AIs can possibly do, because right now their output is non-deterministic. You cannot repeat. You won't get the same code, even the same implementation, if you run the same prompt several times. The output will be slightly different, and this is how the this is the it depends on the architecture of the neural networks, and this means that we will still need to do quite a lot of work besides just generating the code, besides writing the code. We will need to make sure that we have some quality gate that can be used to measure the output. There are different approaches to this. We have discussed a couple of them, like separate testing using some separate scenario, like Gherkin scenario or something else, some deterministic specification of how the system should behave. We can try to define everything in much more detail to make sure that the different runs of LLM using the same specs will produce more or less the same code, but it still be different. So I think there will be quite a lot of work for developers. And besides, the use of AI will make developing some tools, some software for the cases that previously were just not economically feasible. It might not be economically feasible to write some automation for a business that won't be able to afford like a team of developers. And now, obviously, that business will be able to afford some software, and I think this software like development market will be just expanding over time. Okay, but obviously, I think we need to get ready to this and get accustomed to use the AI tools in our day-to-day work, in how we approach the software engineering problems. All right. Hope I have answered this one. Next question. Can this be used by product managers? You mean if it will be possible for a product manager to create the implementation without developers? I think it might be possible for some cases, but the main problem right now with the AI generated code is that you need to understand what AI is suggesting, what it's creating, because only if you have this understanding, you can figure out if the process is going in the wrong direction, if it's probably moving into some dead end, and this feature will need to be completely regenerated from scratch because the current solution won't work. And those things can be evaluated if you have, well, some technical experience, technical background. So for some, I think, simpler cases, it's completely possible to wipe code the whole application. But if the application logic is something that is more complex than a simple web app, or there are some non-functional requirements like handling some I don't know, distributed data, or running some distributed calculations, then that stuff, I think chances are it won't be possible to implement it without some knowledge of how those systems should actually look. At least not right now. Okay. Do we have anything else? Any other questions?
I guess that's all for now. So we could thank everyone who joined us today. Thank you, Ilya. And we hope this information was really useful for you. And have a nice day.
Cool. Thanks. Have a nice day.